You use the same basic steps when you do this to solve the equations. So I'm going to get rid of one of these questions. Hold on a sec. I'm going to get rid of this one. Okay. So step 1 is going to be to distribute. And you're going to do that on either or both sides. So if it's only on one side, you do it on the side that needs it. So basically, you look through and you identify any distribution. Distribution occurs when you have a number outside the parenthesis that you have to multiply in. So here's step 1 right here. I'm going to distribute in that 2, and I'm going to distribute in that 4. Okay, so that's going to give me 2 times 4 is 8. 2 times 2 is 4. The minus 8 that was here just hangs out. 4 times x is 4x, and 4 times 3 is 12. Okay, so that was step 1. I did the distribution. Step 2 is going to be to collect like terms, but only on one side or the other. You don't cross the equal sign yet. Okay, so I'm going to collect the like terms on this side, and if there were any over here, I would collect them on that side, but I'm not crossing the equal sign yet. So this one becomes 8x minus 4, because 4 minus 8 is negative 4, and 4x plus 12 stays the same. My next step is going to be to add or subtract any variable Okay, I want all of my variables on one side. So I want all my x's on one side, and then I want all the numbers on the other side. So I'm going to subtract 4x from both sides. So that's going to give me 4x minus 4 equals 12. Step 4 is to add or subtract any number to the other side. So here I had minus 4, so I'm going to do plus 4 and plus 4 to get 4x equals 16. And then my last step is to divide So I divide both sides by 4 to get x is equal to 4. Okay, and that'll always be your steps. You'll distribute first if necessary. Then you collect like terms on one side and the other side without crossing, if necessary, if there's anything to collect. Then you start crossing. You want to move all of your variables to one side and all of your numbers to the other side. And it doesn't matter which side you pick, just you need to get all variables on one side and all numbers on the other. And it can go right or left, that's okay. So for this next problem, I'll move it down a little. I've got distribution here and distribution here. So I'm going to do the distribution first. That's step 1. So I get 5y plus 5. And then this plus 2 that's just hanging out there stays. And then 4y plus 8. And then that minus 6 that was just there still stays there. It doesn't go away yet. Then I'm going to collect these like terms that are on the same side. So 5 plus 2 is 7, 8 minus 6 is 2. Then I want to get this 4y over on the other side, so I'm going to subtract it because it's positive, and then they cancel out, and I get y plus 7 equals 2. Then I want to put the 7 on the other side, so I subtract it because it's positive, so y equals negative 5. Finally, I'm going to distribute this 4 and this 2, and I'm going to get 4b plus 24, and there was nothing else, so equals 2b plus 10, and then there was that plus 2. I only have to collect like terms on one side. So 10 and 2 is 12. Subtract 2b. 2b plus 24 is 12. Subtract 24. 2b is negative 12. I'm just going to rewrite that up here. Divide by 2. And b is negative 6. So I'm distributing that t, which means I'm going to get t squared plus 4t minus 1 is equal to t squared plus 2t plus 2. And then you might look at that and go, you haven't taught us how to solve t squared yet, which is true of not. However, look what happens when I decide to move all my t squareds together. These cancel because that's the one I subtracted, but then t squared minus t squared is, so that one also canceled. So don't let the t squareds freak you out yet. Yet. We're going to learn how to solve those next. But in the meantime, until you've learned how to solve them, they'll just go away. 2t minus 1 equals 2. Add 1 to both sides, and I get 2t equals 3. And then you go, oh my god, that doesn't divide. Ah! That's okay. Watch what happens. Leave it a fraction. You don't have to do anything with it at all. No, fractions are perfectly acceptable answers. I'm fine with fractions. Algebra is fine with fractions. You guys just don't like them. But this is a perfectly acceptable, 3 halves is a number. It is a perfectly acceptable number. It is legitimate. It is a perfect answer. Just the way it is. You don't have to do anything to it. Yes?
Is yesterday's notes all live?
Yes. But there are 2 methods to multiply 2 polynomials together. Method 1 is FOIL, and method 2 is the table. Okay, and I'm going to show you both methods. And I don't care which one you use. They both work as long as you do them properly. As long as you do them right, they both work and you'll get the same answer. And for some people, FOIL is nicer, and for other people, the table is nicer, and it just depends on how you like things organized. So we'll start with number 1 using FOIL method. And FOIL stands for first, outside, inside, last. And it represents the order that you multiply things in. So when we have our m plus 4 times m plus 1, first, the 2 first things in the parentheses, m times m. So m times m is m squared. And then you have outside, so the 2 edges of the parentheses, m times 1 is m. And then you have inside the two inner parts of the parentheses. 4 times m is 4m. And then finally, you have last, the two ending parts of the parentheses. So 4 times 1 is 4. Once that's been done, you will find that these two things, 99.5% of the time, are like terms. So I will add them together. M plus 4m is 5m, and I am done. Next, okay? So the table method works like a multiplication table. And you guys all remember those where you take the one thing at the top and the thing down the side, and then you go meet in the middle and you find out what the multiplication was? This works the same way. What you'll do is you'll make like a T, and whatever's in one parenthesis, you write across the top and leave a little bit of space. And whatever's in the other parenthesis, you write down the side and leave a little bit of space. And you put the plus or the minus with the number part. Draw a line here and here, and now you have a table. And it works the same as a multiplication table. X times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. So this works exactly the same as your multiplication table did. And when you have this situation, your like terms will line up on diagonals. So I write x squared, and then I have 2x and 2x. Those are both positive, so it becomes plus 4x, and then a 4. I will do these two FOIL, and I will do these two table, just to keep on the same sides. So for FOIL, I do first, outside, inside, and last. And then again, these are my like terms. So I have b squared plus 4 plus 3 is 7b plus 12. Okay. And then we'll do FOIL again. First, oops. So I get 9b squared. Outside, 3 times negative 2 is negative 6b. Inside, 9b. And last, oops, hold on, minus 6. Collecting my like terms, I get 9b squared. Negative 6 plus 9 is positive 3, and then minus 6. So for the table, if you like it better, you don't have to like it better, that's fine. Like I said, they both work. Pick which one you like. T times t is t squared. T times 4 is 4t. Negative 3 times t is negative 3t. And negative 3 times 4 is negative 12. Here's my like terms. So I get t squared plus t, because I have negative 3 and positive 4, gives me 1 positive, and minus 12. using the table again. Also, it doesn't matter if I could put 2m plus 2 here and 3m minus 3 across here. That part doesn't matter. It's interchangeable, so you'll get the same answer no matter which one you put across the top and which one you put down the side. When I have long ones, I usually put the long one across the top just because it takes up less space that way. But it really doesn't matter. Okay, so 3 times 2 is 6. M times m is m squared. 3m times 2 is 6m. Negative 3 times 2m is negative 6m. Negative 3 times 2 is negative 6. These are my like terms. 6m squared. Negative 6 and positive 6 cancel each other out. So minus 6. If you have a 2 by 3, it's not really FOIL exactly anymore because FOIL was first, outside, inside, last. It's kind of like a modified FOIL because you have more numbers. So we're going to do w times w squared, which gives me w to the third. And then I'm going to do w times 3w, which gives me 3w squared. Can you guys see that green okay? Okay. Then I'm going to do w times negative 6 to get negative 6w. Then I come in and I do 4 times w squared to get 4w squared. And then 4 times 3w to get 12w. And then 4 times negative 6 to get negative 24. So the first one times everything, and then the second one times everything. Then we have to look at our like terms. I don't have any w to the thirds other than just this one, so that's okay. My 3w squared and my 4w squared are like terms. So I add those together. I have 3 plus 4 is 7. And then negative 6w and 12w are like terms, so I add those together. I have negative 6 plus 12 gives me positive 6, and then the negative 24 is by itself. Yeah.
Wouldn't w to 3 be the same? Because this is actually 1 w. So wouldn't that combine with...
The exponents have to match.
Oh, the exponents have to match.
Yeah, so this is a w to the third, and this is a w squared, and so they don't match. So they're not like terms. So the letter part, to collect like terms, it has to be the same letter with the exact same exponent. So if you don't have that, then you can't put them together. So those two both had squared, so they can go together, but that's a third, so it's not the same. Okay, so let's do another one of these. I have k times k squared, which will give me k to the third. And then I have k times 3k, which will give me 3k squared. K times negative 6, so negative 6k. Four times k squared, so 4k squared. Four times 3k, so 12k. And finally, 4 times negative 6, so negative 24. This is the same thing as the one above it, but with k's instead of w's. That's dumb.
Did you write it?
No.
Oh.
But look, see, look, WK, 4, 4, WK. It's the exact same problem, but with k's instead of w's.
That's weird.
Very weird. Okay, well, we have our k to the third, which was lonely. 3k squared and 4k squared gives me 7k squared. Negative 6k and positive 12k give me 6k. And then I have minus 24. So silly. Sorry about that. I did not even notice that until I was doing it. Okay, if you like the table method, I like to put the long one across the top, but you don't have to. You can put the long one down the side. It doesn't matter to me. And it will get you the same answer. Okay, so t times t squared is t to the third. T times 2t is 2t squared. T times 4 is 4t. 1 times t squared is t squared. 1 times 2t is 2t, and then 1 times 4 is 4. You still have like terms on your diagonals. You just happen to have 2 of them now. So I have a t cubed. 1 plus 2 is 3. 2 plus 4 is 6. And then a 4 hanging out by itself. Again, I'm going to line all this up and make my table. M times m squared is m to the third. M times 3m is 3m squared. M times 5 is 5m. 3 times m squared is 3m squared. 3 times 3m is 9m. And then 3 times 5 is 15. Like terms are on the diagonals. So I have m cubed. 3 plus 3 is 6. 9 plus 5 is 14. And then there's 15. To have these special products, they always follow a pattern. And the patterns are this. If I have some product and I square it, it's the first one squared plus 2 times the first one times the second one plus the second one squared. And if I have a minus, it's the first one squared minus 2 times the first times the second minus the second one squared. Okay, so if you memorize this pattern, you don't actually have to do the multiplication. Okay, if I look at this, I have n squared, okay, and then 2 times 3 times n, and then 3 squared. So first one squared, 2 times the first and the second, and then the second one squared. Here is x plus 4 times x plus 4, which is the same thing as x plus 4 squared. So if they match, it's the squared. So I can take the first one and square it. I can do 2 times the first times the second, and then I can do the second one squared. So that gives me x squared plus 8x plus 16. You don't have to write this step out. I just want you to see it. Without writing it down, I would look at this and I'd say, okay, that's squared. So I'd square the first. I'd say, okay, 2 times 7 times y is 14y. That's negative, so this is negative. And then 7 squared is 49. So that's why these are nice, because they follow this pattern. So then you don't actually have to do the FOIL or the table. You can still do the FOIL or the table if you want to, but if you learn the pattern, then you don't have to. Yeah. Oh, sorry. Yeah, that should be positive. Thank you. This is the same as t minus 3 squared. So square the first. 3 times 2 is 6 times t, so minus 6t. And then 3 squared is 9. And if it's backwards, that's okay. I'll square the first. 2 times 6 is 12, times u is 12u. And then I'll square the second. And it doesn't matter if they're both letters. R squared, 2 times r times t, and then t squared. So the middle part, the first and last in your answer are squared and squared. And then the middle part is 2 times the first one times the second one. That's the pattern. This is called a difference of squares. That's what this is known as. It's a difference. Well, it's not a difference of squares until we multiply it out, sorry. When you multiply this out, if you FOIL it, you'll get that a squared, and you'll get plus ab and minus ab. Well, those cancel each other out. So the pattern is you get the first minus the second, both squared. So here I have 3g plus 2, 3g minus 2. That's what I'm looking for, is this plus minus with the same numbers. When that happens, I take the first one and I square it, and I subtract the second one squared. So 9g squared minus 4. I have a plus and a minus, 2m, 2m, 3, 3, so that counts. So I'm going to do 2m, and I'm going to square it, minus 3, and I'm going to square it. So I get 4m squared minus 9. And all of these will follow that same pattern, plus, minus, and it can be minus plus, that's okay, as long as one's positive and one's negative, but the numbers are the same. So 3q, 3q, 1, 1. So I have, oops, yellow is no good. 3q squared minus 1 squared. So 9q squared minus 1. Here I have 3p, 3p, 4, 4. I have 1 plus and 1 minus. 3p squared minus 4 squared, so that's 9p squared minus 16. You'll see I'm squaring the number and the variable. 3b, 3b, 7. So 9b squared minus 49. 3y, 3y. 3g, 3g. So 9y squared minus 9g squared. Yeah. Yeah, you always, for this pattern to work, the first have to match, the second have to match, and you have to have 1 plus and 1 minus. If they match and they're both pluses, it's this situation. Or if they match and they're both minuses, it's this situation. For this to work, there's 1 plus, 1 minus. There's already exponents in here, and I'm squaring it. This follows the pattern of the a squared, or a plus b squared. So I take the first number and I square it, and then I do 2 times the second number times the first number, and then I take the second number and I square it. Follows the same pattern. So I now have n to the 4th plus 2r squared n squared plus r to the 4th. And here's a squared with a minus. So I'm going to take the first number, oops, well, that's fine, and square it. And then the second number times 2 times the first number, and then the second number and square it. So this will give me 9t to the 4th, and then I have 2 times 3 is 6, nt squared, and then n squared. Or you could put tn squared, that's okay too. That's fine. And likewise, if I have, say, x squared plus 5, x squared minus 5. Just because these have exponents doesn't change anything. I'm going to take that first one and I'm going to square it. And I'm going to take the second one and I'm going to square it. So it would be x to the 4th minus 25. Okay, so if you see exponents already in the parenthesis, don't let it make it seem like you have to do something new or extra or different. It's the same pattern.